Hello guys, welcome back to CodeLens, where we venture into the uncharted waters in Matter software. If you are new to the channel, feel at home and be sure to subscribe and turn on the notifications so you'll be notified when I post a new video. Now let's get to the objective of our today's episode, where we are going to have a look at internal microservices communication via a message broker, or in this case event bus. And to be specific, we're going to utilize RABBITMQ as our preferred choice. Now, as a recap to our previous episode, which you can find on the link above, we did create the user service and we were able to use Axon framework to implement a CQRS kind of an approach, and we were able to create a CRUD application where we were able to create, save, update, and soft delete the users. Now, in this particular case, we are going to implement internal microservice communication such that our use case is going to be when a new user has been created, we are going to publish a message to RABBITMQ on a specific queue, and we expect that in this case the notification service is going to subscribe to that particular queue, and when a new user has been created, we expect that that particular user is going to be sent, let's say, a notification. In this case, it could be an SMS or an email. All right. Now, without further much ado, let us get started. Number one thing that I would like to mention is that I went ahead and created some certain modules that we will be implementing, or basically we'll be using in our continuous episodes. Now, this particular module, as you can see from my screen, is called the commons module. All right, this commons module, the only thing which I did, if we can have a look at the POM XML, I only added the Spring Boot Starter, AMQP, and Lombok. All right, now inside these common modules, I did create a AMQP package, a DTO package, and also the utilities package. Now, let us start with the utilities package, where I created a class called Constants, and inside this class, I have the representation of the queue names that we are going to be utilizing in this particular episode. So for this one, we are calling it ticketing users queue. Now, going ahead, we are going to have a look at the DTO package, which basically is just a user DTO, right? Which of course implement a serializable interface. We are going to see that we need to implement the serializable interface so that our simple message converter that RABBITMQ template is going to use is able to serialize this message so that RABBITMQ can be able to persist this data. All right, going ahead, I did create an interface. In this case, I called it the broker producer, all right, which is going to expect a type T of the payload. All right, so that is why I created this just type T payload. So basically this is just a generic interface, all right, which one of the methods is that it is send payload to broker, which expects a payload of type T and to the destination. So this destination basically means to which queue should we send this particular payload. Now, if we have a look at the implementation of this particular generic interface, I have a class called broker producer implementation, which implements the generic interface. Now, as you can see, the only thing which we are doing here is now implementing our send payload to broker. All right, the first thing that I did, I created a Rabbit template, which I auto-wired through the constructor, basically the constructor injection. And in here, the only thing I did is that I said, when this method is being invoked, that is the send payload to broker, send this particular payload to this destination. So I'm using the Rabbit template dot convert and send. All right, so it's going to convert and send this payload to the destination that we are going to set. And the last thing that we need to do in here is now to create, or basically to define a bin which Spring AMQP is going to auto detect as it wires up. All right, so I went ahead and created this particular bin, okay, which I just called it users queue. So I'm just basically returning a new instance of the ticketing users queue, which is the one that we created in the constants file. And then inside there, we are just returning a new queue, and we are saying that let this particular queue be durable, all right, so that even when RabbitMQ is stopped, any messages on it will not be removed. All right, now having said that, I went ahead and also created our new service called the notifications. So let me first of all close all this. Let us have a look at the notifications service. Now, this is at the moment, this service does not have any special kind of an implementation. It's just a pure Spring Boot application with no logic whatsoever. All right. So the only thing which I did, I added the module, the commons module to this particular service, and as you can see, this is a dependency that I added. These other dependencies are the ones that we've been using all along the previous episodes. All right, so we have the PostgreSQL, we have Lombok, we have the Spring Boot Starter Web, we have the Spring Boot Starter Data, JPA, etc, etc. But our interest for now is this particular dependency, all right, which we have added, which of course references the common modules that we've created. All right, also inside the user service, let me collapse this. Inside the user service, under its POM XML, I also added the same dependency. All right, the reason I did this is because maybe, as you're aware, I can be able to utilize some of the maybe DTOs or some of the logic that we've implemented in our common modules. All right, so that we can utilize or basically reuse the common functionalities that we are going to be having. All right, now one thing that I also did is under this package called listeners in the user service, I created a dummy listener for when a user has been saved. Let us have a look at first of all our logic. Now, as you remember, this is our user service projection where we did most of the CRUD operations. All right, now, and as you can see in here, when a user created event has been published, in here we only come and create a user, right? But I went ahead and created this user DTO that we saw in our commons module, which in return I'm sending it to this particular queue. So let me reverse a little bit. Now for this user DTO broker producer is basically this is the interface that we created. If you remember, we said this broker producer expects a type T payload. All right, so in here I went ahead and specified my current payload T is going to be of user DTO. So this is the POJO that I intend to send data with to RabbitMQ queue. Right, so I did create the broker producer. I did, of course, an constructor auto wiring. All right, so as you can see, this is where I created this, and I annotated this with at lazy because there was a circular dependency. So this kind of solves the circular dependency issue that was there. All right, after doing this, I went ahead and created a bin representation of our interface T. In this case, a bin representation of broker producer of type user DTO, and that's just it. All right, so this is where now I'm using this user DTO broker producer to come in here and say the user DTO broker producer dot send payload to broker. Then I'm sending the user DTO payload to this particular queue. So now to test if this dummy listener is working, we are going to wire up our infrastructure. So if yours is also not running, I'm going to do a docker compose, then I'm going to say -f, then the docker compose file, which in our case is called the infrastructure, then up. All right, give it a moment or two as it wires up. All right, one more moment. One moment. So if we have a look at the infrastructure compose file, remember we said these are the dependencies in which we are using for our particular microservices series or course for that matter. So we expect that RABBITMQ is going to run on port 15672, right? As you can see, this is it. We actually exposed two ports, but this port is just going to be used for internal communication. But the GUI interface is going to be accessible through this port 15672. So let us make sure that it is up and running as expected. So localhost 15672. All right, so the username for now is guest, and also the password is also guest. Awesome. Now as you can see in here, we have under queues, I already have the ticketing users queue, which of course is a classic type, and it is durable, and its auto deletion is set to no. All right, the next thing that I am going to create is, now I'm going to wire up the user service. All right, so let us run the user service. Give it a moment or two as it wires up. All right, one moment. So I'm going to create a user created event. All right, so I'm going to create another. We're going to push one more request and see if, when a user has been created, if we will be able to see this message being sent to our broker. All right, so let me come in here and say, let me create this user. So let me, for the name, I'm just going to for now call it broker message test. Okay, for the address, I'm just going to call it sample address, maybe AMQP, name it whichever you want. Then in here just a dummy phone number. Awesome. So let me push this request. Okay, it's at 200. So let us see what happens. Now as you can see, we were able to create, we were able, number one, to publish an event, which we handled it using our event handler, and the user was created. Actually, let's make sure that indeed that user was created. So in our users all endpoint, let's see if the user was created, and as you can see, here is the user. Now one thing that you notice in here is we are saying sending payload this blah blah blah, okay, to the ticketing users queue. Where is this being called? It is being called from our user created, is basically being created from our user projection. So let us come in here and say, if you remember in our broker implementation, okay, I'm just going here. All right, we are saying sending payload, whichever the payload it is, to this particular queue, and in our user created listener, we are basically listening to messages that are being pushed to this particular queue, and we are basically logging that particular POJO or data that has been posted, and it is exactly what we are seeing right here. Right, this is a payload that has been sent. So this listener is being handled at still our users microservice. So we need to put this kind of an implementation to our notification service, and then we can be able to see if, when we publish from one service to another service, if those two services are going to communicate with each other. Right, so the only thing that I'm going to do in here is just come to our listeners, then under notifications service, I'm just going to create another package. Then I'm just going to call it again listeners. All right, let me call it listeners, and as I've created this one, I'm just going to utilize the same kind of a logic. So I'm going to call it user created listener. So the first thing that you need to do is make sure you mark this as a component, all right, so that Spring can detect it. I'm going to utilize also SL for J, at least this is Lombok specific. And then the last thing that I'm going to do in here is now create our rabbit listener annotation to our method. So this method does not have to be called listen, you can call it anything that you want. So to make sure that indeed we are calling this from our notification service, I'm going to add this kind of a metadata or annotation, basically additional data. So I'm going to say notification service event listener, okay, listener, so that we can differentiate that indeed our notification service is able to receive the events which have been published from user service. Okay, so I'm just going to replace that, and in here, the same way that I've done here, I'm going to add this data. Okay, so it's supposed to be now user service event listener. Okay, so I'm going to replace like that. Awesome. So let us now rerun our application, then we create a new user and see if we are going to see the changes that we expect. So I'm going, number one, to rerun our user service. Give it a moment. All right, there it is. Let it wire up. So as you already can see, this is again is not something which is complicated to achieve. It is something very much doable, and you should not be scared on how to implement it. All right, so our user service is up and running. I'm also going to come and wire up our notification service. Okay, give it a moment. Right, as you can see on this tab, our user service is running, and on this tab, our notification service has already started. Okay, now the first thing that now I'm going to do is let us create another user. Okay, let me say duplicate message broker test. Okay, address, so just going to say that. Okay, phone number, just a few modifications, sorry. So let us send and see what is going to happen. So at 200, so let us see if it has received. Okay, so number one, user service event listener has been able to receive this particular payload. On the other hand, the notification service, number one, it has not yet received. So let us have a look at why that is the case. Okay, so one thing that I'm going first of all to troubleshoot is I'm going to stop the user service. Okay, user service, let me drop that for now. Then let me first of all do this. Okay, let me now run my user service again. Actually, I'm just going to run the two services. One moment. So the user service is up and running. All right, sending payload. Okay, having done that, the user service is up. Let us run our notification service. All right, and now as you can see, I think the notification service, I think it had not wired up correctly, but now as you can see, we already starting receiving the notification service event listener. So let me push another user created. Okay, so I'm going to send 200. So what has happened? As you can see, we already receiving the data. Here it is. duplicate to, okay, this exact payload that we have sent. And as you can see, we have been able to achieve a scenario whereby two microservices are able to communicate with each other. So in here, this is where you normally now do your logic and implement. You can say implement, maybe implement your preferred, let's say implement maybe your preferred SMS or email notification logic. Okay, so for example, you could even in here now create your maybe Twilio implementation for sending SMSs. For example, you could use maybe even SendGrid for maybe testing or maybe sending email to this particular user. You could even go ahead and also now create this user, right? Create this user on the notifications database, right? You can follow the same method or logic that we did when creating our user in our user service. So the question here comes, why should we even do that? Now remember, number one thing about microservices is that each and every microservice should be able to be self-sufficient. So in the event that the user service is done and we want to send, for example, a notification to customer X or user X, we already have a materialized view of our user. All right, so you'll find that also the notification service is going to have basically, should I call kind of a replica, but the exact term that you call is a materialized view of the user's data. All right, now having said that, this brings us to an end to this particular episode. But before we leave, I have a challenge for you. All right, number one is I have a question. So what do you think will happen if you start the user service, create a user, then publish the event to the RABBITMQ queue that we've just created while our notification service is down? What do you think is going to happen? Let me hear your thoughts on the comment section. We can even discuss it further. Now, as a challenge also, go ahead and create a payments service module, add the commons module dependency just like we have added in our notifications and user service, and then create a listener which is going to listen to events or basically to messages that are going to be pushed to, again, the ticketing users queue, and then implement a Postgre or MySQL database to persist again the user's data that is going to be sent to that particular queue. All right, so having said that, have a good one. I'll see you in the next one. Goodbye.